Hello everyone, this is Brony Calc, and today we're going to be covering the ARML individual round from the competition 2 weeks ago. But I think I'm going to try something a little special. For those of you who don't know, the ARML individual round is presented in 5 pairs of problems where you're given 10 minutes to do each. So as a challenge, instead of just going through them one at a time, I'm going to try to do each pair in 10 minutes. Got my stopwatch here, and we're going to give this a go, starting with the first pair, and begin. So, for this problem, we have numbers of the form n to the n, where n is an integer, so all the way from, we start with 1 to the 1, 2 squared, 3 cubed, go all the way up to 2017 to 2017. And we want to know how many of these are perfect squares. So, we want to figure out what types of numbers will form perfect squares when written as n to the n. So let's try something. We know a perfect square has to have an exponent of 2 and some integer on the inside. Let's write that integer as n to the k, where k can be anything. It can be 1 or any other positive integer. Same goes for n itself. And let's try rearranging it a bit. So, if I just expand this out, we get n to the 2k, which means a positive integer to any even power is a perfect square. Which, some of you are saying that's obvious, but it helps to check this stuff so you don't make any dumb mistakes during the test. So, if the exponent is even, then our whole thing is a perfect square. So since we're dealing with n to the n, if n is an even integer, n to the n will be a perfect square. Now let's try swapping the exponents because we can do that. So we have n squared to the k. We know this is the same as n to the k squared, which is a perfect square, obviously. So a perfect square to any power is also a perfect square. Since we're dealing with n to the n, that means if we have a perfect square, that's also going to generate a perfect square. So we're dealing with perfect squares and even numbers. So we need to figure out how many of each we have. We're going from 1 to 2017, which means our even integers are 2 to 2016. So there are 1,008 of those. And then for perfect squares, we have to find one that's nearby. Fortunately, if you know your things ending in 5, you know 45 squared is 2025, which is just bigger than it. So we have 44 perfect squares. So we are almost done, but we have to remember there are even perfect squares. So if our perfect squares are 1 through 44, we have overcounted 2 squared to 44 squared, or 22 numbers. So just subtract that out, and we get 1,030 as our final answer. So problem 1 done, and we're only about 2.5 minutes in of our 10. So we have plenty of time to spend on our second problem, which goes like this. We have a trapezoid ARML with AR and ML parallel. Now, trapezoids with AR and ML is going to sound familiar to everyone who did last year's individual round. Or was it year before? I don't remember. You guys can tell me in the comments. I'll probably cover it eventually, actually, if you guys want me to. So, let me know. And we're given that AR equals 4. RM is the square root of 26. ML is 12. And LA is the square root of 42. So, we want to find AM. So there are a few things we need if we're going to find AM. First, let's just drop this down and call this D. We need AD and DM. To find DM, we need DL. So, we have X. I'm going to switch it around actually. I'm going to say this is 12 minus X. This is X. So, and this is H. So we know that H squared plus 12 minus X squared equals 42, and we're looking for h squared plus x squared. Now, we don't quite have enough information yet. We could start guessing and saying it's an integer, but we don't really want to do that yet. So, let's drop another one. Let's drop RE as a perpendicular. We know that this is also going to be h, and so, since these are all right angles, this is going to be a rectangle. This is 4. So we have x minus 4 right here. So now we have another thing. H squared, plus x minus 4 squared equals 26. So, now we can subtract 1 from the other. I'm going to subtract this one from this one. We get 12 minus x squared minus x minus 4 squared is equal to 16. And then we can use difference of squares to get, we sum these together, and that is 8. And then that's 8 times, we subtract 16 minus 2x is equal to 16. Divide, this is 2, so we get 16 minus 2x is 2. 14 is 2x, and x is equal to 7. So we know what x is, and we can quickly check. 12 minus x is 5. 42 minus 25 is 17, so h is the square root of 17. And when we add those together, we get 49, which is 7 squared plus square root of 17 is obviously 17. 66, so am squared is 17, and am itself is square root of 66. So, at this point, we have gone through both problems in about 6 minutes, so we have a little bit of time to talk. Oh, there's not much else to talk about, actually. I guess like, comment, subscribe. Tell me if you enjoyed this idea and want to see more of it, which I plan on doing for the rest of 2017, but let me know if you want me to do other years. And I will see you all next time.